right, we're going to take a look at question 145 and 146. So let's do it. Question 145 says, a researcher conducted a survey using a simple random sample of 50 voters. So first I'm going to write out a simple random sample, just abbreviate it here as an SRS. And it looks like N is 50. Now it says we're going to use this to create a confidence interval to estimate a proportion. So we're not sure what that proportion is, but it's definitely a proportion question because we're going to ask the voters if they'd vote for a candidate for mayor. And that would be a yes or no question. So it says, assume that the sample portion doesn't change. Which of the following would best describe the anticipated effect of the width on the confidence interval? So I'm going to look at my formula for a confidence interval, and it states that the statistic plus or minus the critical value times the standard deviation of the statistic. And if it's a proportion question, the standard deviation of the statistic is this formula right here. So this goes right here, and the critical value we are going to assume stays the same. So I went ahead and copied that down. The confidence interval is whatever my statistic is, the proportion of people that said yes or no, times my critical value, times whatever my standard deviation of the statistic is. Now we know, since this is a proportion question, that this is the formula. So the most conservative way to approximate this is to set the proportion as a flip of a coin. So let's assume that the proportion of people that said, yes, I'm going to vote for that candidate is half. Then 1 minus half would be another 0.5, and we are being asked to assume that N is 50. So this standard deviation of the statistic would be this calculation. So 0.5 times 0.5 divided by 50, take the square root, would be 0.07. So this would be the number that I would plug in here, and then the critical value is usually 2. So I'd take 2, or around 2, I'd take 2 times that number, and that would be my plus or minus. Now we know, because we've said it many, many times, as N goes up, my variability or my spread goes down. And we're going to see that actually happen here. So when we increase N to 200, if I approximate that the proportion simply half of the people say, yes, I'm voting for that candidate, then half would say no. When I divide by 200 and take the square root, notice I get the number 0.035. And when I compare these two, I can see that by changing N from 50 to 200, the width of the interval would go down by 1/2, because 0.07 is half of 0.035. Now let's take a look at question 146. It states an automobile brake pads are either metallic or non-metallic. An experiment is being conducted to determine whether the stopping distance is the same for both types of brake pads. So we don't know which one's better, which is why we're going to do an experiment. In previous studies, we figured out that car size is associated. So you might think of a two-way table, because that's a test for an association. You could do a chi-squared test for an association. And the car size would be small, medium, and large, perhaps. And they did the study already, and they noticed that the size of the car did help tell us this stopping distance. Short stopping distance, let's say medium stopping distance, or it took a long time till you finally stopped. So somebody did a study and noticed there was an association with this. However, when they studied the car type, sedan, wagon, or coupe, they noticed it wasn't associated. So this makes me think of the classic experiment they did on diets when we cut out soda. Now, the reason I bring this up is because I think many people know that when women cut out soda, that tend to drink a lot of diet soda, they lose about 5 pounds over the course of a month. When men stop drinking diet soda, they lose about 15 pounds over the course of a month by merely cutting diet soda. That's the only thing they change. So that's very frustrating for women, but notice that we've established there is an association. So me knowing whether or not you're a man or a woman will help me predict how much weight you're going to lose if you stop drinking diet soda. So because we recognize there's an association here, that's why we've invented this design type of strategy called blocking. If I didn't block men and women in my study with diet soda, then I would think, and I would tell women, hey, stop drinking diet soda and you could lose 10 pounds, because as long as I take an average of men and women in the same amount, these two numbers would average to 10 pounds. And so I wouldn't be lying if I walked around telling women, hey, cut out diet soda and you'll lose 10 pounds, because that's what the average person loses. And that's true. However, when we blocked the study, we recognized it's true the average person loses 10 pounds, but the average woman only loses 5 pounds. So there's definitely association there. Similarly, in this problem, we're told there's an association in relation to the car size. Therefore, because of that, we want to block on car size. Thanks for joining us.